So doing the same thing, we notice we're going to have to rearrange. Negative y, if I add y to the left and add y to the right, take away 1 from the right, take away 1 from the left, that gets rearranged as y equals x minus 1. So there's my equation 1. Now I can look. I've got y-intercept and a slope. My y-intercept is negative 1, a slope of 1. Remember, if the coefficient's 1 in front of a variable, we don't have to show it. That means up 1 over 1, up 1 over 1, up 1 over 1, up 1, and I say over, but it's to the right. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Keep going. I can continue the other way. Let's draw it. Now, for equation 2, you do the same thing. I'm just going to use some of the space here. So if I look at rearranging that, it's the same thing. Maybe I'll add 2y to the right, add 2y to the left, take away 2 from the right, which means I'm going to take away 2 from the left. And that whole thing, and you do it here, now is 2x minus 2 equals 2y, which again, left side equals the right side, so I can put it in a form that I'm maybe more familiar with. Now I need to isolate y equals mx plus b, so divide by 2 to the right, or to the left, and then do it to every other term. Divide by 2, divide by 2, divide by 2, and I've got y equals x minus 1. So I've got a y-intercept. I got a slope. So I plot those points. Negative 1. Slope of 1. Up 1 to the right 1, 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 point, up 1 to the right 1, point, up 1 to the right 1, point, up 1 to the right 1, point. And I noticed something. I've already got those points written down. So let's draw line 2. And line 2 ends up being right on top of line 1. So where do these points touch, or where do they cross? Well, they cross everywhere. Or at all the points. They're basically the same line, just written 2 different ways. So we say that that has infinite solutions, because they're the same thing. They're right on top of each other. So now we have some possibilities. 2 lines can either cross once, never. What do we call lines that never cross? Oh, parallel, that's right. Or they cross everywhere. They have infinite solutions. They're the same line. Okay, flip the page. Let's put that all together. 2 lines that have one unique solution. They have one unique solution. So that means they have, let's start with slope. They have different slopes. Right? So different slopes, and they could have different y-intercepts, but could be the same. If they have the same y-intercept but different slopes, then that y-intercept is actually where they cross. So one solution, we're going to have different slopes, different y-intercepts, but it could be the same y-intercept. So again, we have 2 lines that cross at one point. 2 lines have no solutions, then they have the same slope or equal slopes. And they have to have different y-intercepts. That tells us these are parallel lines. They're never going to cross. There's no solution. If two lines have infinite solutions, they have the same slope, as well as the same y-intercepts. So they are the same line. They're right on top of one another, even though I've drawn them slightly side by side. So, which one of these is not equivalent? Which one is not the same? Well, we've got it in y equals mx plus b. So why don't we turn the other two into y equals mx plus b so we can see. I'm going to take away 2x from the left, which means I take away 2x from the right. I can decide the order. So I'm going to put negative 2x minus 8 out front. I need to get y by itself. Divide by negative 4, divide by negative 4, divide by negative 4. Y equals negative 2 divided by negative 4, positive a half x, negative 8 divided by negative 4, plus 2. Well, those don't look the same. So those are different lines. Different slopes, different y-intercepts. There'd be one point of intersection between these two lines. So let's compare this one. Take away x from the left, take away x from the right, add 4 to the left, add 4 to the right. What remains? Negative 2y equals minus x plus 4. Divide by negative 2, which means we're going to divide by negative 2 for each of the terms. Negative divided by negative is positive 1/2 x. 4 divided by negative 2. Negative 2. That should be a positive x. Or a positive 8. So there's the negative 2. That'd still only be one point of intersection there. Again, different slopes, different y-intercepts. They're not the same. So one point of intersection. And we look at what are similar. Those are similar. Those are the same line. So between them, there would be infinite solutions. They'd be right on top of one another. Okay. For these two systems, without actually graphing them, could we see if the point of intersections are the same and then explain? So we got equation 1, equation 2. Different slopes, different y-intercepts, so we have one solution. 1 POI, point of intersection. Over here, we're not sure. We need to see, are they the same? Do they have the same slope? Do they have the same y-intercepts, or are they different? So let's rearrange. We call this equation 1. I'm going to add 2y to the left, which means I'm going to add 2y to the right. So for equation 1, and if I follow it down here, I've got 2y equals 2x minus 2. When I divide by 2, excuse me, I've got y equals x minus 1. That looks like that one. For equation 2, I'm going to do the same thing. Let's get y by itself. So I'm going to take away 6x from the left. And then I'm going to take away 6x from the right. For equation 2, I now have 2y equals, I can choose the order, so I'm putting my negative 6x term first, then plus 14. Let's isolate to put it in the common form that I'm used to seeing a line. And I have y equals negative 3x plus 7. So these two lines are actually the same as those two lines. Different slopes, different y-intercepts, so they would also have one solution or one point of intersection. One point where they cross. So would the point of intersections for these two systems be the same? Yes. Because they're the same sets of two lines. They're the same systems. We could then either graph it or use some of the skills from the next lessons to figure out what that point actually is.